Okay, good morning. I'm discussing about buffer solution. Buffer solution is an aqueous solution that resists change in pH upon the addition of small amounts of strong acid or strong base. Classification of buffer solution: acidic buffer. Acid buffer solution is mixture of weak acid and its salt with strong base. Mixture of weak acid, acetic acid, and its salt, sodium acetate, which provides buffer solution. Basic buffer solution is a mixture of weak base and its salt. It's called basic buffer. Mixture of weak base, ammonia solution and its salt, ammonium chloride, produces basic buffer. Mechanism of buffer action. Action of acid buffer solution. Let us take an example of acid buffer solution of mixture of ethanoic acid and sodium ethanoate. In the solution, ionizes as flow. Ethanoic acid ionizes ethanoate ion and S plus ion. And sodium ethanoate also dissociate ethanoate ion and sodium ion, highly ionizes. Sodium acetate is a strong electrolyte and undergoes almost complete dissociation. It increases the concentration of acetate ions, which acts as common ion in the solution and suppresses the ionization of acetic acid. The solution consists high concentration of acetate ions and low concentration of hydride ion. Addition of acid: when the quantity of acid is added, it produces H plus ions and it combines with ethanoate ions to keep the feebly ionized acetic acid. So the addition of H plus ions is neutralized and pH of the buffer solution is almost unchanged. But due to increase in the concentration of ethanoic acid, the equilibrium shifts toward the right according to Le Chatelier principle. This fact justifies the marginal increase in pH of the buffer solution on addition of acid. Addition of base: when the little quantity of base is added into the buffer solution, the hydroxide ions combine with hydrogen ion to form the feebly ionized water. This shifts the equilibrium, shifts to the H plus in OH, hydride ion and hydroxide ions into water. On the other hand, upon addition of hydroxide ion in buffer solution, which combines with acid to form water, which undergoes feebly ionization, acetic acid and hydroxide ions also produces ethanoate ion. Due to this reaction, concentration of acetic acid is decreased than its concentration initially. So concentration of hydride ions is also slightly less, which justifies for the marginal increase in the pH value of the buffer solution. The mechanism of buffer action can be summarized as below. An addition of hydroxide reacts with hydride ion and produces water, acid buffer, and hydride ion addition produces acetic acid. Action of basic buffer solution: The mechanism of basic buffer solution is can be explained. Just consider an example of mixture ammonium hydroxide in ammonium chloride. In aqueous solution, this undergo ionization as follows. Ammonium hydroxide ionizes ammonium ion and hydroxide ion, which is feebly ionized, and ammonium ion and chloride ion highly ionized. Due to complete ionization of ammonium chloride, concentration of ammonium chloride is large in solution due to presence of common ion ammonium ions. The equilibrium shifts towards the left and ionization ammonium is suppressed. Addition of acid. When acid is added into basic buffer solution, the hydrogen ions combine with hydroxide ions to form feebly ionized water. In this way, the solution neutralizes the hydrogen ions of acid. The same mechanism can be explained as follows. When the acid is added into buffer solution, the acid combines with ammonium ion hydroxide and hydrogen ions is neutralized as follows. At the same time, same instant, the concentration of ammonium ions is increased, which acts as common ion. They shift the equilibrium to the left, which decrease the concentration of hydroxide ion in the solution. Addition of base. When the hydroxide is added to the buffer solution, it combines with the ammonium ion and form ammonium hydroxides. The same things is explained from the literature principle. When the hydroxide is added, the equilibrium is shifted to our left side and the concentration of ammonium hydroxide increases. The addition of hydroxide ions is nullified and pH of the solution is maintained. The process are summarized as the addition of hydride ion and hydride ion reacts with the hydroxide and produce water. When ammonium addition of hydroxide, ammonium ion reacts with hydroxide and produces ammonium hydroxides. Calculation of pH of buffer solution, pH of acid buffer solution. Let us consider an example of weak acid as and its salt is with a strong base B in a aqueous solution. This ionized is the AC. Ionized into S plus A minus feebly ionized, B plus A minus highly ionized. For the ionization of weak acid, K equal to S plus A minus over AC. So you can write AC plus equal to K AC over A minus. Here A minus is the concentration of anion. Salt is highly ionized and produces more concentration of A minus. Due to common ion A minus, the equilibrium force shifts to left. So concentration of A minus in solution is almost due to ionization of salt B. If so, salt equal to A minus and acid AJ. Now equation 3 is expressed as S plus equal to K acid over salt. Now taking the log to the both sides, minus log is plus minus log K minus log acid over salt. So pH equal to pK minus log acid over salt. pH equal to pK plus log salt over acid. So equation 4 helps to calculate the pH of acid buffered solution if concentration of salt and salt are known. Equation 4 is called Henderson-Hasselbalch equation. Piece of basic buffer solution. Let us take an example of weak base BOS and its salt with strong acid BA. In aqueous solution, this ionized is BOS, B plus OS minus heavily ionizes, and BA, B plus A minus highly ionized. For the ionization of weak base, Kb equal to B plus OS minus over BOS. OS equal to Kb BOS over B plus. B plus is produced by heavily ionization of weak base and complete dissociation of salt Ba. Due to common ion B plus, the ionization of BOS is decreased. So concentration of B plus in the solution is practically due to dissociation of Ba. So salt equal to B plus and base BOS. Now the equation first can be expressed OS equal to Kb base over salt, taking log on both sides, minus log is plus minus log Kb base over salt. So minus log hydroxide OS minus equal to minus log Kb minus log base over salt. So we can write POS equal to PKB plus log salt over base. So equation 2 helps to calculate the POS value of basic buffer. If the concentration of salt and base are known, equation 2 is called Henderson-Hasselbalch equation. Significance of Henderson-Hasselbalch equation. The pH of the buffer solution can be found out if the concentration of weak acid or weak base and salt is known. Dissociation constant of acid or base can be calculated. The Henderson-Hasselbalch equation is pH equal to pK plus log salt over acid. When the concentration of salt is equal to the acid, then pH equal to pK. We know that pK equal to minus log K. Similarly, value of Kb can be found from the relation U is equal to pKb plus log salt over base. The equation has to prepare buffer solution having the desired pH value by monitoring the concentration of salt and acid. Buffer capacity is defined as the number of mole of acid or base required for 1 mole like buffer solution. For the change in pH of the solution by 1 unit, buffer capacity is the defined number of mole of acid or base required for 1 liter buffer solution. For the change in pH of the solution by 1 unit, buffer capacity equal to number of mole of acid or base added per liter of buffer solution over change in pH. Buffer range is the pH range over which a buffer solution can be effectively resist change in pH when a small amount of acid or base are added. From Henderson-Hasselbalch equation, it is revealed that pH of the buffer solution depends upon the ratio of concentration of salt in acid or salt or base. When concentration of salt is equal to the concentration of base, then we can write POS equal to PK of plus log 1, 0. So POS equal to PKB. Similarly, when concentration of salt is equal to concentration of acid, pH equal to pK plus log 1. So pH equal to pKa. When the concentration of salt is 10 times greater than that of the acid or base, or POS equal to pK plus 1 and pH equal to pK plus 1. So when the concentration of salt is 10 times smaller than that of acid or base, POS equal to pK minus 1, pH equal to pK minus 1. For an acid salt buffer is effective buffer range pH minus pK, pH equal to pK plus minus 1. This means that buffer works best when the pH of the solution is within the 1 unit above or below the pK. Similarly, for base, pOH is equal to pKb plus minus 1. Importance of buffer solution. Buffer solutions are used to keep the pH of the solution almost constant. Buffer solutions are mostly used in industry for alcoholic fermentation, pH range 5 to 6.5. Buffer system of carbonic acid and sodium carbonate is found in human body. The pH human blood should be within the range of 7.35 to 7.42. The secretion of acid or base physiological reaction is required to be buffered. Ions present in the ocean perform the buffer action, which is necessary in marine ecosystem. Ammonium hydroxide in ammonium nitrate used for the precipitation of basic radicals in the qualitative salt analysis. Act is buffered. Okay, it's all about buffer solution. Thanks for watching and request you all like, comment, share, and subscribe. Thank you for patience. That's now. Bye bye. See you again.